I will start. My name is Alexander. I've been quote unquote for a long time. Well, if we judge by the blockchain, all the projects, long-term projects, I've been doing this whole blockchain development thing for some time. I've been doing blockchain smart contracts. I've also started to figure out how do they operate. So let's first talk about this very weird topic that we call development of storage. If you have at least once taken a look at Bitcoin, at Ethereum, of Exanum, there are lots of other. You saw something that we call level DB. Please, let's try raising our hands. I love raising hands because almost nobody does sports, and sports are very useful things. So, what is level DB? Has anyone heard about this? Yes. Okay. RocksDB? Anybody? BerkeleyDB? Oh. Those are the same people that raise their hands. I have a suspicion that they're being taught this at some high-level investors. The thing is that a lot of projects take those things as is. They try to plug it into their projects, and because of this data flow, their data flow completely splits, fudges, and sometimes they get a concurrency problem. Let's add it with mutex and those kind of hunches. They get lots of, and they're everywhere. And in particular, this presentation I'll give in the level of graphene chains because bitshard graphene they're using something that's closer to file storage with a huge number of projects, and it's a transition phase to use this as a foundation, to use it as a small base. It will become clearer to you. So the speech itself is almost the final thought on how to do it all together. Because when we talk about databases, no, this is not too good. We might have some technical issues because we're also showing the presentation from my laptop. Okay, sorry, I'll wiggle my finger around a bit more often. No, we're not talking about scripts. This laptop is set to turn off to go to sleep as often as possible. Getting back to this will be a pre-final slice on what is the base, where do we need to plug it in, why do we need to write memory store for them, what are those trees, how can we create a storage. So let's try to start. First, we're talking about graphene technical family, graphene chains. They're on BitShares, or in BitShare is the original, and graphene is, for those of you who don't know, they took out the marketing part and say that now this is called graphene. So BitShare and graphene is almost the same thing. So graphene is BitShare without marketing. They had storage that was very close, both in structure and mechanics. It was closer to file systems because they were not solving the problem of writing 2 MB without any input lag to the hard drive. They were waiting for this. They were having great trouble with this, and it was done in asynchronous and synchronous modes. And I thought that wow, this must be painful. Then we have this timid coming to this as a kind of a logical follow-up to this. Then we move on. We moved away from the storage that we had. We've tried to do a newer storage because in this for the presentation for this presentation exists. There is also a version that ended up in EOS with some other overhauls. But now let's talk a bit more about all this. Some of graphene-like chains, they look like this. Uh, is it clear to you? There's nothing too innovative in them. Let's speak a bit about input and outputs. In this case, we're talking about WebSocket. Let's take a look at the first input. And every kind of node has its own WebSocket server. It has a P2P synchronizing part because as soon as the data that have to end up in the chain, the modifying data, they send to the chain. So for the add a node to store it on the network, then we do the validation, and then they end up on the chain. And if it starts to overheat, then P2P starts to overheat. Then we start some asynchronization, and then we start having some problems on the chain. This is how it looks to the external observer. Oh, WebSocket started to overload. It had 3,000 of heavy connections on it, and we started to get the asynchronization. This is how it looks to the external observer. By the end of the presentation, we understand that this is not the case. Let's review the second case. We also have this P2P part. You also have what we call the Replame Sync, or the other smart term for this one. The whole chain is being uploaded from network, and I tried to reload it to get the fresh node. When out of the P2P, it goes on chain. And if some of you know, C++ uses the plugins they have for every signal, and then they update every index that are custom for the plugins, creating a sort of extension of knowledge about everything that is on the chain, because almost all graphene chains, they are more about replication and about how on this post factum we build first database, and then to look at everything that was on the chain. Then we start to have the chain overheating, because you take a look at EO stat, and it tells them that the UI is more than 10 milliseconds, and you go, wow, what's happening? And you think something in my life went awry. From that point, we start to have lag from plugins, because the plugins, they allow us to develop different kinds of mechanics that come from chain. After this, the WebSocket server, when it exhausted all the opportunities to create the characters, then it works with a very funny scheme. Then it starts to respond in any way, at least the WebSocket server, after which the node enters the state when nothing they get nothing in return. It says nothing, but then it all goes through the system smooth away, and it seems that everything is normalized. It seems that the system was imbalanced. It fixed itself. No, it's just time and a huge amount of hardware allows us to solve this issue. And from that point, we understand that we start becoming the external observer. We start using our brains and taking a look at the inside and what's happening in the inside. And every picture, we saw that they all intersect at this at one place, at the storage for the chain. And what you're doing as the smart developer, you go and take a look at what's happening there on chain. Those are the slides that I got out of this. What's that? Almost all the time. Much better. So those are the weird locks that we got for a long time before we had several major changes that were implemented 6 months ago. We were having the situation every 2 or 3 weeks, and we didn't know what to do. Well, let's fix everything. But things got 3 months ago. We implemented the latest fixes that fixed it, making the DevOps a happier one, a more sane one, because there's nothing worse when the DevOps is not ready to work on his project and says that everything is really bad. We made DevOps happier. We got more love from him, but those are all nuances. You start to figure out what's happening inside this thing, and you think, but I'm seeing certain kind of index abstraction, some abstract of the table. It must work. It must work in PitchAir and Steemit. It's quite logical. You are a developer yourself. You take a look at it. You start playing around with it. Yeah, there is something like table boost multi-index container. Well, does anybody know what boost is? Well, come on, boost, boost, Hana, boost processor. There was one hand I saw it when I was talking about C++. No, there's one person that's nodding. Yes, inside it's boost multi-index container, but there is one nuance. They introduced a boost interposer locator in it, what makes him quite happy, quite lively. How is it connected in Linux? There's this abstract that's called share memory, and it shows the same way on the hard drive. So it might not be completely true what I'm going to say, but for it to for the meaning, it shows in the system files with which the operating system works post factum. And if we're talking about a pseudo file or a piece of the sumo file, it goes to the cache, allowing you to really quickly search for it, not going to cache and any other things. Yes, it's quite nice. I think that this scheme works. Smart people coded before you, so it must be the right way. And as soon, for the time that I'm working, I get this feeling, but actually it turns out to be wrong. And you think, okay, so let's take a look a little bit at how this boost multi-index operates. We do have a certain structure. It has a certain margins. We do have the we do have the initial indicator get 8001, or to be able to take it out with certain conditions. What do we have inside it? We do have a semi-continuous memory shard in which there are all those entities. You are you are searching for it with a pseudo index written on templates during the compilation time. At runtime, it's very hard to add anything to it, but it was originally planned, so the concept is clear. 7.8 will review a certain example. We do have a person. He has an identificator. He has a name and age. Does anybody get any question about sex? No? It's written differently. Sex is no. The thing is about type of data. The data type here is int. So, who knows what is the maximum number? What is the maximum digit that we can use int with? The problems that nobody knows. Well, sometimes my jokes fall flat, but let's try. On this, we do have lots of personals. We tried to do an index by name. It works. We do have an index age, something weird, but it also operates. We try to do an index sex. It operates, but actually, we what we get out of this, what has to take a little space takes a lot of space. Then you start playing around with the allocator, understand how fun it's, it is there, but it's connected to the fact that within this allocator we have a red and black tree, and it operates certain segments of memory, and at the time when you want to input more, there is no free space, there's no free segment, so the tree rebalances, and during this interesting moment you get this tree, and it seems to be balanced, but it also seems to need to balance more. And if at this moment, we give, if at this moment we give a moment, we understand why those red and black trees and allocators, they were not designed for those kinds of loads, and sometimes it's the flaw that we get at the stage of design. This is the storage. This is what our storage looks like in Steemit and in EOS and post factum. Anything. Wow, those were smart people, intelligent people who wrote this. We have an interface here. It's stream secure, non-stream secure. We do have this mighty boost multi-index container with an allocator. We do have the synchronization mechanic for this. It must have been written, must have been coded by smart, intelligent people. So let's figure out how does it work in real life and not in theory, because I can speak about this for a long time. We do have, I'll tell you, uh, the scheme is very low level. Some details are omitted that are not important, that are not too important. We do have a piece of shared RAM. Sometimes we have it in memory. It's reserved by the system for everything to go smoothly. We have different ways to to project this to the HDD. Let's try. We do have a virgin clean chain. We start to load it block by. We start to load RAM block by block. First, it goes to the RAM, then it goes to the HDD. We we put it to the HDDs for us to keep some versions, for us to be able to check some versions, so that for us to check that we're not overlaying data on VR, but we can check hashes. But in other databases and other mechanics, they have revisions, which seems quite a logical thing. It also has its revisions. What happens at the time when we have a new block that updates old data? We have the version 7, and we have both on shared RAM and HDD, and we have revision 8, which is only in RAM. So first, when we validated the block, it started to update the part that's in the RAM. So then it starts to nullify the part that's on the HDD. Given this, the red and black tree within the allocator allocates and deallocates pieces of memory. So it tries to push it to the very end, not to dislocate. And this is the load that creates huge problems when we replace it for a hash map inside instead of this red and black tree. Following my humble estimates, 8 has to stop those lows on the memory, and second, it has to increase the performance boost allocator by 1.5 times. We have talks with people from the BIOS community on how can we add a modificator to this allocator, but as of now it's quite painful and it also hurts the performance and does not suit everybody. So it's all really fun, but after we've updated everything on the HDD and RAM, we delete the segment that was updated and validated. Then maybe it's me who is this evil person who turns off nodes when they're under load, and I still need to reproduce this kind of situation. From this point, the storage lock. Remember move lock 917? Do we remember this? Do we remember where this story began? First we have block, and then the sync doesn't actually happen. So if nobody remember this, why are you still listening to me? Okay, well, nonetheless, let's move on. We move on with this really scary story, the story on how to write this, and then you start to look at the thread safe part of this. The unlock is not clearly visible. It's not clear why do we have this lock. When you start to check thread safe logs, you go to thread safe, and then you see this beautiful magical scheme where you have your mutex, but there's nuance. Those mutex are also very special. They're also in shared RAM. They're also with the same allocator that's mapped to the file system. Although formally logs we can really do lots of simplifications, but they still work in their own system, and you think, okay, well, something really does go wrong in my life, but you still continue to play with it. You continue to try to reproduce the situation that we saw earlier. Yes, I'll have to turn off Dr. Sandelov. This is the only way to actually reproduce this story. And the second moment is you take a look at how boost multi-index container behaves when you use different tracers for different methods to learn what's going on with the RAM. You try to poison the RAM because you know different ways of patching the when Silang's brought their sanitizers, you know dirty hacks how to take those sanitizers, how to patch it, so to get a really tricky output for the soul. And after this, you understand the following, that you have lots of mutexes that operate, that work. They're really cool. Let's presume that one of them has locked. They're all in RAM, so everything is kind of fine with them. Another one got locked, and in a certain time we transfer the data from shared RAM to HDD, and what's going on? The locked mutexes end up on the HDD, and then suddenly unload with we try to recover this node, and then in the shared RAM those segments of memory that were in mutex, they end up being locked, and those mutexes are unable to unlock themselves. And through this we got a very funny story on how to unlock the mutexes. First of all, the first way is to drop it all, and this is where the mute log 917 comes from. It's a thing I know that in my presentation I like memes. I need to make it funnier, I need to make it more interesting, but it's kind of a hardcore presentation to scare off the people and for them to come better prepared. When you get it back from the HDD to RAM, can we oversee this moment? Can we control this moment and work on it? Well, the protocol is to ask questions on the spot. Okay, there are tricks in this. If we don't get into the design of the boost processor and boost shared mutex, which goes with this, you can't do it. And when you go into this, you break a lot of things in other places. Or you'll get the following, where you have boost of version 1.58 patched, then we'll have the original boost 158, then we need to join them in the base, and it becomes a very complicated task. So yes, you can do it. I was able to actually manage this, but first of all, sometimes the patches are not accepted, and generally it's just hard to maintain. Maintenance costs are very important things. When you need to also do 50 custom libraries, then we start having questions to you. Why do we get this? And we follow this way. We've taken a look at this magic once again, and we've understood that without extensive research, we're unable to do this. We need to really give it a thought on how to fix it all, and we've started to think about this. First of all, it's good we need to move away from the storage on the HDD that's being implemented through segment manager from boosting the process mechanics. It's a very weird one, but we actually are able to either do it in the file or somewhere else. So we decided this is a very good thing to do it, to do RocksDB and all our projects while RocksDB. We can replace a locator different from what we have in the system. It's very comfortable. We do have some features connected with it when your application works with JLock. It's really pleasant. Then we've understood that this hell of a memory storage in which we have these conflicts. We went for the way through to move away from the shared RAM to store it in RAM. We know how to do it. The process will really work smoothly, and we understood that earlier we could launch 6-7 points on one copy of application. It will work, but actually it's nothing like this. Even in those mechanics, it never used to work, and we understood that Docker container there will launch one of our nodes, and everything will be really beautiful. When we talk about revision mechanics, it has also changed a little bit, but not too much. We have the situation there where we use, instead of the boost process allocator, we just use version update and labels. So from this point we got the segment that's close to us, that's next to us. We've validated it. Validation mechanics is quite difficult, after which a small part of RAM updates, and then it all goes to the HDD, and then we delete this as a concept. It kind of used to work. I had a semi-operating prototype that only worked on a part of my test, on the part of test production, and you might think, okay, let's get it to the production where we have done a month's work in 1 week, but no, it doesn't actually work like this. You start to plug into rocks, something is production ready, but it's painful, it's expensive, it's dangerous, and you start to think, why do we need all that? We need to think a little bit and understand that it does look kind of like this. This is kind of a cute picture. We had a machine gun here that shoots all the developers' feet that agree that we need to do it like this, but I decided that it's cuter. That's why we took another approach. We used the old interface as the foundation. That's why we took the way those queries look to the post multi-index container, and we've said that it's basically our main interface, and we're starting to add our new interface piece by piece. Then we have a layer that unites the queries from old API and the new API, everything is quite understandable here. Then we have the logic layer. Why did we need the logic layer? In the old database, a lot of types of data validation was written within the code in that specific place. We could not afford this because when we got rid of the old code and surgically cutting it out with a scalpel, we were not able to make everything really well, so we had to introduce an intermediary validation layer that first allows us to validate data, and second, it allows us to guarantee the correct data changes, so that we don't have any overflow when we serialize the line, and all those simple manipulations that from first glance seem very obvious. Then first we had them in the code, now they are here. Then we do have some kind of synchronization layer, at least in the prototype, and we've just started to write it in RocksDB. It seemed to be really well, but every time a query that updates all the layers and writes it to the RocksDB was too slow, so we've decided to add a snapshot mechanic. Why did we decide to do this? Because we have a current state of database. It's warm, but when you do have a lot of changes add up, we do have this situation with RocksDB, and in case when you need to protect from node turning off, and when between this and the last thing we had some critical time pass, we've added this abstract which is called Snapshot, to where we put the hottest data. Now I'll tell now in more detail about how it operates inside. So you address one of the layers, and then you address the interface part that interface thread safe components to itself, and it has the magic how out of 30,000 threads to correctly handle everything. Then we have validation of the data type check. From that point we do have the synchronization, and after this, when the stage when it's in rocks, we do have the snapshot coming, and after we've updated the snapshot, the synchronization layer got the message that everything is well. Then we've updated the RocksDB. This is how the life cycle for it all looks like. Let's go in more detail now on how it works inside. We came up with such an abstract as database. There are more than one of those. We've decided they'll be as line identifiers when we ask to get the database to get the comment, and in comment I want to introduce a collection which is called comment content, so everything works well, and database can have more than one collection in it. Within this collection we do have a composition key, which is a compound key which carries more than a unique identifier. It consists of some kinds of meta information, so that we don't do an index for every move, but so that we'll be able to search for it without index, but still with performance. And the second part is the document store, but document store, it's first, on the one hand, document store on steroids. On the other hand, it's a bit has anybody here used Python to write code? Only one person? Python? Who knows what tuple is? You know that having created it once, you can't change its size in terms of the number of elements, but if within it we had a dynamic object that got there in a cunning way, the object will not change, but everything that's stored below you can actually change. It seems quite a logical thing. It seems quite an operating thing. What does it give us? We're limiting tuple. I will also limit the number of elements in tuple, but tuples themselves will be. Has anybody worked with Elasticsearch? One person. Okay. There is a JSON-like structure there, but the actual scheme we can only license it once, and from that point to continuously add data only in this format. If you change the format, then this whole thing tells us, no, I won't work like this. everything's bad. So we try to follow the same type. If we there input one time to our collection a document, the very first one, and a certain kind of a pseudo scheme, quote unquote pseudo scheme. So if we done this once with the database, we record this as the correct set of input types. So we do a kind of a mix between document store and tuple store. Thus, we get a certain kind of a mix. Why is this a mix? On the one hand, we do have a dynamic document store because there you have lots of objects input there. At the same time, you do have a certain kind of limitation both on the number of elements and also on the megabytes that you can dislocate within, and also the amount that can be used within. Remember, we do have those permanent type that we say once and they hold this thing forever. And as soon as we know that in this place we'll have an int, we can use lots of optimization and to allocate pieces of memory they're not. On the document store we can use those on ints, on double clouds. Thus we're able to get rid of some excessiveness that used to be before, and we make everything simpler, make everything local. Then we have certain kind of information. Composition key only gives us this in brackets if you've provided for this in advance. It gives us certain kinds of system things for the memory, for the storage memory operation, for the operation when you need to recover this, actually the information on the composition key. You cannot do a meta information. You cannot do metadata from the composition key, but you can get the composition key from the metadata for the correct recovery of the HDD. For this, we've done this feature when we are no longer closely tied to RocksDB. It allows us to do a lot of features, but we can do a kind of a generalized solution. Not just saying this because we've done this for RAM, because we have 2017, 2018. RAM is getting cheaper by the day, so we can have lots of RAM on servers. That's why we've tried to move away from the paradigm of storing everything on the rocks. We try to also store everything in this kind of document. Let's clarify here. Why did we choose this design? At the same time, as in first of all, it's the document style, but also we do have an element of table style because we want to sum it on some kind of a pseudo column to sum up something or to address something that's within our line. In this way, we get our mix. Also, theoretically, we can build indexes that will index not only the first level of all types, but also several levels of inputs. We do have certain types of papers for the next year. I have a plan to release it all as a library that might be usable in JavaScript. I really want to do this. I don't know whether it'll actually happen or not, but it'll still be cool. Then let's move on to the trees. Actually, everything that you've seen before is some kind of manipulation with trees and with different options and types of trees. Trees that have hash maps within every node. It looks a bit different, but the meaning is basically this. We do have this very weird scheme when we're speaking about database levels. We can put in hash maps, works really nice. We don't need to have a difficult choice between bases. When you work with collections, everything becomes a bit more difficult. Within one collection, we do have an internal tree that has to manipulate those composition keys. So you must have some complex selections on those values because there might be some index that you might need to go and choose. So we will operate with P3 trees because we do have maths for it and it's quite clear, but my colleagues' research tell that LSM trees, if we mix with B-tree, really give out good performance, and it seems that it all looks about making it more dense, about allocators, but what we come up with as a result, in the result, everything is not finished yet. We'll see it a bit further on. We'll try to input new objects. Why am I speaking about trees? And I will speak a lot about trees from now on. It's connected to the fact that it's one of the few abstracts that we can really cook well for it to be competitor friendly. If you love Google, I see that sometimes you distract yourselves in Google. You can read there what are multi-version data structures. This is a really good thing for to do this at home. You can discuss with me. I'll be able to tell you. We'll talk about the simple implementation that we wanted to do. We're going to take mutex and take this. Mutex is a very cool and simple, robust thing that is not everybody. We can use an RV mutex at in the beginning of our collection. It works with one client there. The step is 1 second. Two people try to install it. Three people. It kind of overloads, kind of overheats, and understand that the weight that ping might have there of 300 milliseconds, and it's too bad one to for it to be quicker. So when I was looking for different papers on the internet, everything we've seen before, this is the very same meaning. When you have lots of clients and everybody is trying to grab mutex and to input data, when the selection of trees when they go to the depth takes a long time. This slide, everybody likes the slide somehow. I don't know why only this slide is really liked by everybody, but okay. When we start thinking about how to get rid of the problem of having too many blockages in other mechanics, I understand that there are not a lot of selections. You need to introduce some kind of an abstract version. Who knows what is MVCC? Who knows what multi-versional currency control? Who knows what this is? I have a question to you. We do have one person that knows about this. What scares you in this acronym, multi-versional concurrency control? Okay, so let's decipher this acronym. When you try to do something in this reduction for the base, you don't block everything and at once. When you know that in this moment, when you learn that in this line you want to change a subline for this kind of data, we do have this copying of the version. We know that it all happens there. Then we do the update, and then we do have an atomic swap. So you do have a kind of a paper sheet, and all the pages there are numbered and cut. And as soon as you need to introduce a new sheet, you don't put there a new list, but you put on a small part that has been prepared in advance, a small part of it, and then you put in a new one. It's you didn't used to cut tickets in your childhood. No? Okay, so we have a tree. We try to input something where in root, and from that point we try to find the part of subtree that we need. Then we'll find this part of subtree that we need, and we'll link to it the element that we want to replace, and we want to replace the element that's on the edge. Sometimes we have the situation where we have a certain number of iterators, and they're looking at this. If it's all wrapped up in the transaction, we cannot replace it. We need to take a clearer look at this, and after we understood that we don't need any more of this, you switch, you do something that was used to be the old version, then you note the old one as something that's not needed. Yes, does everyone hear me well? So after this, for some time you can erase this object. Thus you get this kind of a replacement. At the same time, you don't have this high number of blocks, and it's quite nice. You can leave, you can tell about this, and everything starts working for you. So only 2 weeks ago, this scheme, Absurd, started to operate in the scheme. Absurd is when it's not an update and not an insert. Some kind of a mix between those two. When you don't have any data, the input there is, if you don't have it's there, if you have them there updated, they started to work not long ago, and I got really happy because this code is a bit scary. I will come to a close as of now because I've exhausted almost all the limits. I do have a GitHub, and I hope that by the end of the month I will upload the first working I will upload my first small task, and I will be really glad about this. I'm ready to get all kinds of feedback on this. If it's unclear to you, you can write me an email. I will also send you a link. That's it for me. Do you have any kinds of questions, offers, ideas, propositions? I'm answering. I can answer all kinds of questions. Let's have a round of applause uh, for Alexander. Thank you very much, Alexander, for your speech. We were actually able to endure it. If you have any questions, you can ask them. Oh, we do have a couple of people. Yesterday, I did some work on researching projects that are doing smart contracts in Denmark. This asynchronous graph, this weird asynchronous graph with weird terminology. I'm not too adept in maths in this meaning, so to you as a specialist, I'd like to ask this: is it actually real smart contracts in those kind of systems that follow IOTA principle? Smart contracts in IOTA. I'm not really familiar with IOTA blockchain. They use consensus algorithm. I know people that are more adept in consensus validation mechanics. They tell that it works for sure, and they have some already written code that Mandala Plus proves that this actually works. And I think that if consensus will not work, then most likely we'll be able to work on those smart contracts. For simple cases, the case that we have in EOS, let them pay me something in EOS. It might not be too difficult. I'm not an IoT specialist, but there are suspicions that it can be done, and it's quote unquote, it's not too quote difficult unquote. Hello, thank you very much for your presentation. I have a very simple, stupid question. I just wanted to ask you where do you work? Do you develop your own blockchain and everything that you do with this storage? What are the real life use cases for this? On your project, I I'm doing those kinds of things for myself. Those are my personal developments. I work in Steam and I also work in Golos. I do development for them. Also, I develop those cool things. Golos.io. Yes, it has a massive blockchain behind it. If you take a look at this table, did anybody, did everyone like cats? Okay, well at least you liked one slide. It was me who drew this cat, and the problem is that I'm more of a developer and sometimes speaker, but I'm not an artist myself, unfortunately. When I have all the tests, please touch out to answering your questions and comments and metadata. We didn't just take them out of the blue. We tried to do it step by step, and the thing is that the mechanics of data flow of the model that we have and the way that it operates now is almost a it's almost the pain it's almost a pain to go from one storage to another, to replace one storage with another. We cannot just take and draw an all. Remember the things we had in child. This when we want to just take shared RAM and take it to RocksDB, it didn't work. So we need to do those things with trees, with hash maps of trees, and this is what we do. That's being easy swapped, and I remember that we can upload it to. We are talking about snapshots. The thing is that We don't always want to write it on rocks because sometimes we have a problem when you have to wait for a long time, and there are some problems that don't allow you to do this quickly, but snapshots allow you to replicate a piece of RAM HD, not only quick but also quite comfortable. And it seems to me that you recommend to use the existing bit shares and offer that to do any kinds of projects on blockchain, not to take just bit shares but to modify them and only then to use it. Can I say, well, if you have the task to launch it to enroll a chain that will count money and will be a shadow master for distributing and allocating resources, it's your option. And it seems to me that user comments can include 128 megabytes maximum. How do you imagine for the file system for the HDD with SSD would take 128 megabytes straight? It's impossible. And with those kind of tricks, you can do this. Yes? Well, now we do have hellish freezes, and if the bouncer is not too high, that holds lots of Docker containers, and this we do have examples of when it works. To develop MP step by step is. I hope that I've answered your question. I think that for every task, for every kind of task, somewhere the bit shares will be able will be okay for use for money for currencies, but somewhere like Golos IO it does work. Yes, it was me uh, who took on this challenge. I was the main person behind writing the stories because without this we might not have business. If the business feature is nice but the technical implementation is bad, at some time it will operate, but then we'll have the breakdown, the so-called breakdown. I wanted to continue on the topic of who are you and what do you do. I'm writing code in C++. There's my GitHub. Well, judging by the names of the tables that we had on the line of the slides, CoinDB and anything, so you put to the database quite voluminous data, comments to some kinds of posts on social media, social networks. Can you tell a bit more on what exactly do you do and how do you use those databases and what are the queries to those databases? Okay, short content of my presentation from the very beginning. We don't have our own CDB. Everything that you heard up to certain slide was a boost multi container with interprocess with an addition of 30 or 40 my patches for it to work. This is our database. Within it you have a simple selection, simple spaghetti, and then you have a more complex selection. We're not talking about what's inside, we're talking about what's outside. You are inputting the comments there. You know Steemit and Golos is a blockchain platform. So when you want to post something to anybody you want to put it into the blockchain, everybody will have it, and you cannot block it. Was I able to answer your question? Well, Facebook on blockchain. I like Facebook more. Something that we put on the blockchain, everybody has it. But you do have a database, and database provides for some typical queries to it that have to be implemented quickly. I understand, and I'll get back to the slide. Unfortunately, I'll be clicking through for a long time, and blockchain is a combination of all those components, and it seems to me that this part of the storage is designed with a chain, and I'm not constraining P2P. I'm not constraining anything, but we all know it those all biggest components, plugins, because they store the biggest part of it, and P2P is mechanics of synchronizing the chain that's here and now, and this is the uh, mechanics, and if we will learn a chain to operate as quickly as possible, and let's solve the performance issue. What I'm telling now is we don't only need to speak about graphene chains, everything that I'm telling now we can take as a certain kind of library, and in the future in any of your projects to input there as a certain kind of a distributed storage. I'll try to clarify my question. Storage cannot be generalized. If we're doing this, we input certain kinds of requirements with muscle. Is MySQL, what databases do you work with? So my Oracle, MySQL and Postgres, yes. Are those what you call generalized storage? Yes, but besides storing data, they also provide you the possibility to quickly access those data to process those queries. Do you work more with MySQL or with Postgres? For me to answer in more detail. Okay, let's say Postgres. Postgres, there are Oracle masters, and let's speak about Postgres. If you do, for example, a column for 15 elements, you give them some names, and each field you'll do in JSON-B, you'll get what I had on my scheme, and every point is mutable. Actually, the raw is the same in Postgres. The design might be a bit distant, but the meaning is the same. Permanent type gives you certain kind of optimization so that we don't have JSON-B everywhere, but in certain spaces it will be not JSON-B in brackets, but double or int or big int. And it seems to me that in my view I want to achieve some simple selections. I don't want to work with this whole subset. I want to do this key document store on steroids, but without all those mechanics. So let's do select summary. I don't want to do this. I want to do a have of possible of range selection, the opportunity to get it out quickly, to get it in quickly. But from that point, it depends on your business logic. From that point, do I understand correctly that the question was to create a special kind of a DB, but on the blockchain, almost. The requirement is to create a certain kind of library out of which you'll be able to get SUDB for you that will not belong to a certain kind of consensus that is not. There will be some things for threads where you do it will be a thread specific. It will be connected to the fact that it will be a library and not a kind of a magical framework. I love the word framework. It will not be a framework, it will be a library, and it has to be a small b simple. The task there is not to write a new blockchain. The task there is to change the storage chain for it to be best for the cases where it's needed. And will it all work only within your blockchain? Golos, my task is to make it a generalized one and to upload it to GitHub. Thank you very much for your answer. I really like Critic. Critic allows the project to move forward. Actually, we also have a very ambitious task to upload lots of data on the blockchain. So it's a very interesting topic, and I would like to talk to you later on. I'm ready for useful communication from both sides. Do you have any more questions?
Baby.